many aspects of life we take for granted. At home, at work, and in our leisure time, we enjoy an ever-changing combination of new products, behind which lie complex stories of commercial enterprise fueled by demand and competition. It is this commercial pressure which originally gave birth to an area of scientific analysis we now call surface science. A science which aims to determine the chemistry of those top few layers of atoms across the surface of a material. It is a field where VG Scientific have become a world leader in the development and supply of analytical equipment to companies such as Sony, Toshiba, Ford, Exxon, and IBM. VG Scientific plays a major part in making Physon's Instruments one of the world's leading manufacturers of analytical instruments. Professor Jim Castle is head of the Department of Materials Science and Engineering at the University of Surrey. He's been working with VG equipment for more than 20 years.
Material science is all about the development of new materials. We've all had the experience of abandoning hickory wood for carbon fibre in a golf club, and of plywoods and tennis rackets for carbon fibre laminates. In a man-made material, components of different origin are bonded together, so the best properties of each component are realised in the final article. And of course the bonding has to go through the surfaces. It's the surfaces of each component that we're bringing into contact and which we have to make into some kind of permanent bond. The first fibres were glass, and glass fibre products were transformed the market in the 70s, but the ultimate strength of carbon fibre and the ultimate weight of carbon fibre for a given strength is very superior to glass fibre. And of course, to develop new products and to develop new resins, it's necessary for the scientist to actually have a measure of the degree of surface treatment and of seeing how that itself relates to the impact strength and the fracture toughness and other materials properties which are important to the materials scientist. So we make our machine to have a vacuum of the quality you would find in outer space. And under those conditions, we can fracture a sample, create a totally new surface, and that surface will remain in that state throughout the whole of the working day. One of the problems of man-made materials is that it's possible for flaws to appear. The flaw, in this case, could stem from a region which, for some hiccup in the process, has become poorly treated. This poor treatment will lead perhaps to delamination occurring locally, and that delamination then can spread throughout the whole of the composite material. The important thing for the manufacturer is to know that all the carbon fibre yarn which is used has a surface which is typically represented by the spectrum we see here for the treated material. Looking at the screen now, we can see on the treated fibre not only the peak for carbon, which we expect from carbon fibre, but also a very strong peak for oxygen. The untreated fibre has the peak for carbon and a peak which you can just see for oxygen, which in terms of surface chemistry is quite trivial.
There is a wide range of products with which we are all familiar that have benefited from surface science. New, light but strong materials used in the manufacture of aircraft, advanced protective coatings for cars. Even the production of contact lenses has made great use of surface science procedures. But where does Professor Castle think that the future of surface science lies?
All analytical techniques have a cycle. They start as a phenomenon which is being investigated by the physicist. They're taken over by the chemist and eventually by the engineer to control the process. Once we get to the engineering level, we'll find that the person using it is much more concerned with the quality of the output of the articles he's making than with the essential physics that was being studied originally in the research labs.
The surface science experts at VG Scientific are world leaders in these techniques. Their instruments play a vital part in developing the many new products and materials which we all take for granted.